This is a construction site of a Touchstone Energy home being constructed by Iowa Central Community College's carpentry class. Their instructor is Bill McAnally. Hi, Bill.
Hi, Mike.
Good to see you today.
Good to see you.
Say, it looks like you've done a lot of things already. You've got the foundation established and walls poured. What have you had to do in order to make this a Touchstone Energy efficient home?
Well, one of the first things that we have to control is moisture, and to control moisture we bring a lot of rock, and we put 2 to 8 inches of rock underneath the floor, 6 to 8 inches of rock underneath the foundation and the footing area, and we also bring it up around the outside to keep moisture from getting up to the side of the house.
Okay.
You can see on the foundation wall that we have a peel and stick style of waterproofing. You can use a spray on or roll on, but we chose to use this particular product in this house. We have to be able to control that moisture because there's so much that's going to be exposed on the exterior. So we've put 2 inches of extruded polystyrene on the inside, and underneath the basement floor we have 1 inch of extruded polystyrene to insulate that basement floor to keep it warm so we don't have any mold issues down the road. We also have a vapor barrier underneath that slab to keep radon gases and moisture from coming up, and that also keeps the house a lot drier, a lot easier to control.
But what have you had to do in order to make this ready to be a Touchstone Energy efficient home?
Okay, let's walk down and take a look at it.
All right, sounds good.
Well, this is a peel and stick waterproofing that we've applied to the outside of the foundation. The foundation wall is actually 8 feet tall, and we've already done some backfilling with some clean limestone chips. Below the foundation wall we have a concrete footing, and then there's gravel underneath that concrete footing that also helps the groundwater to get over to the sump pit. Our goal is to keep the insulation dry and to keep the basement floor dry. Right below the foundation wall, if you go straight down, right as it hits the top of the footing, there's a capillary break that prevents any moisture from coming up the wall and then possibly attacking the wood through moisture.
Now, the insulation this time is not on the outside. Is it preferable one way or the other?
In this particular application, we had to use the insulation on the inside because there's so much of the foundation above the grade.
Can we go ahead and take a look at what you've done on the inside?
Sure, let's take a look.
All right.
This is the 2-inch extruded polystyrene that's been applied to the interior of the basement. It goes all the way down to the top of the footing, so it also insulates where the actual floor meets the wall. We've got the capillary break underneath this, and then this carries right up to the top of the wall, and then where it meets the band joist, that's an area we've already insulated on the outside with foam, so we can always add more insulation up in there. Plus, we can always add more insulation to this. We'll eventually mechanically fasten this with some wood furring strips to be able to attach your drywall. If you can keep your floor surface warm and you carpet it like a lot of basements are, then you won't have any mold underneath the carpet. There's always that issue with that if the carpet sits on top of an uninsulated floor that you could have mold growth. We have a vapor barrier underneath the floor to stop any moisture vapor and any radon gas from coming in. So then that all gets trapped over to this sump pit. This particular type is called a jackal pit, and we can pull all of the radon gas out of this and exhaust it if there is any radon issues in this particular house.
Excellent, excellent. Well, it looks like there's some things going on upstairs. Should we go ahead and take a look at that as well?
Sure.
All right. When I saw this going up and saw your students working on it, I thought perhaps they'd done the corners wrong at first.
Right, right. A lot of people think that. They think that the more wood, the better. And in the corners, that's the absolute wrong way to think. What we're trying to do in a corner, because there's lack of air movement that's in a corner, is we want to keep these very, very warm, and so we've got to eliminate a lot of the wood. There's no structural value to having all this extra wood except to hold this piece of drywall.
Okay, so this is recessed then, so you can put more insulation here?
Right, this is what's called a two-stud corner. It's been around since the 40s, but for some reason it's taken a long time to take off. What we do then for drywall is we either apply a corner bead, drywall corner bead, which is a 90-degree angle, or we use scraps of, say, floor sheeting. We'll attach those to the back of this stud, and that way the drywall can come over. And then there's only one stud drying, and when there's only one stud drying, we just don't have any callbacks for drywall cracks anymore.
Okay.
While we're building these, a lot of people will say, well, where's your plywood sheet?
Yeah, they're used to seeing that.
Sure, they are, and we don't want any of that product on the walls. If it's a high wind area, maybe so, but we'll still put foam on the outside.
Okay.
And the reason we do that is this foam then acts as a thermal break.
And so that way the cold air or the cold temperatures can't travel through the sheeting, through the stud. And then, you know, you hear these stories or see on TV where you'll see shadowing or ghosting is what they call it.
Right.
That's
Of
because
course.
the stud is so cold that the moisture inside the house condenses and the dirt in the air hits that, and you see all these dirt spots.
That's what causes that.
That's what it is, yeah.
Okay.
And they always blame it on candles. Well, the candles just produce the soot that sticks there.